Hi there, welcome to the Research Like a Pro with DNA question and answer series. I'm Nicole Dyer, and today we are learning from Diana Elder about what is meant by coverage in genetic genealogy. And coverage is such an important topic, especially when we're trying to prove research questions that are so far back in time that we're dealing with a lot of smaller matches, matches that are 40 and 30 and 20 centimorgans. And coverage just means that within the database that you're using, whether it's Ancestry or MyHeritage, getting more test takers that represent more of the tested descendants of that research subject to share their DNA results with you or to be able to view them. So even though with Pro Tools you can see how much people share with each other now, we still need to get better coverage, meaning asking additional tested descendants of your research subject to share their results with you so that you can see those matches that you don't have in your match list, that they have in their match list. Because sometimes we don't inherit the same DNA that our cousins inherit from that ancestor. And we might not inherit very much DNA from that ancestor at all, whereas our cousins might inherit more. So they might be the key to unlocking the answer to that research question that we're not able to break through. So Diana's going to share some answers to this question, and she's also going to share her example of her Benjamin Cox research project, where she was able to increase the coverage of Benjamin Cox through asking cousins to share their DNA results with her. This is an excerpt from our Research Like a Pro with DNA office hours, so I hope you enjoy it.
Okay, and I believe our last question is about coverage. So coverage is something we talk about a lot, and I've hinted at it a little bit earlier in the session. And the question is, please explain what is meant by coverage with respect to DNA matches coming from a variety of children of a research subject. Do we assess coverage based on a number of siblings with descendants who match, a test taker? Do we assess based on length of segments that triangulate? What DNA data constitutes proof or at least strong support for a hypothesis? Or do matches descending from various children of research subject mean nothing unless correlated with documents that prove relationship? Okay, these are all such good questions and something really valid. We've talked a little bit about this idea of triangulated segments. We've talked already a little bit about proof, but let's go through coverage and then see if we can just add a little bit more to this. So coverage in DNA testing, it refers to how much of a particular ancestor's DNA is represented in your pool of DNA matches. So we all know this. Each person inherits only a random subset of the ancestor's DNA, and any one tester might carry only a small fraction of the distant ancestor's genome, even none at all. And of course, this gets less and less as we go further back on the tree. So by testing multiple descendants of the same ancestor, you cover more of that ancestor's DNA. In other words, coverage is the amount of a research subject's DNA that is represented in a database through their combined tested descendants. So high coverage means you have DNA data from many branches of the family, increasing the odds if you truly descend from a given ancestor, some segment of their DNA will appear in your matches. For example, if your great-great-grandfather had 5 children, each child inherited a different mix. You might inherit only 6% of a second great-grandparent's DNA, and distant cousins inherit other pieces. Testing descendants gives a more complete picture. So we want to get a lot of cousins. And before we had Pro Tools and we could see how much DNA different people shared with one another, we would ask them to share results with us. But now we can get a little bit more information with our Pro Tools, but we still want to really think about how much DNA we have for an ancestor. So an important thing is to look for coverage across the ancestor's family lines. So we call this independent descendant lines. We want to have, if possible, descendants coming from each of the children, if not from each one. Let's have DNA matches coming from a good group of them. So we don't want to have everybody coming down through just one child of the ancestor. Matches descending from several different children is much stronger evidence that the ancestor is truly our forebear. So we have to have testers from multiple children's lineages. So how do we measure it? Well, we can look at the number of descendant lines covered, and we can see how many people we have per line. Sometimes we have lines where there's only like one or two descendants, and other times we have just a ton of descendants coming through a line. And then, as we talked about earlier, maybe we've got good coverage here, a good number of matches. Then we could also see if we could find some segment data and triangulation, which would just add one more piece of evidence. Is this always necessary? Not necessarily, but it can be really nice and can be helpful if you can find them. So a good tool to use is the coverage tool at DNA Painter. And here's the test tree or the sample tree that Johnny Pearl gives us. And it's really easy. If you've never yet used the coverage tool, I would highly recommend trying it out. You put in your ancestor, you can easily put in their name, birth and death dates, and then you put in their children, and then you start putting in their children. And when you come to someone who's taken the test, you mark them as a tester, and then they turn into the black. And then you start getting a feel for how much of the genome is covered. So in this case, with these three test takers, we've got 48% of the ancestors' genome covered. And so this is exciting to see when you start filling in all the different people, the numbers go up. And so this is a good way to test and see what you've got. And then, finally, the DNA evidence that will really strengthen our hypothesis, those multiple matches from multiple lines, some triangulated segments, and then clusters. We really want to have clusters of people that all match each other. We can add Y-DNA or mitochondrial DNA results in some situations. So all of this put together, the triangulated group of cousins, multiple separate matching lines, and documentary evidence can all really help us feel confident that we have confirmed the identity of an ancestor. So genetic evidence is often the key that unlocks the question, but we still frame it as part of a broader proof argument, which brings us to our final point, that DNA is just part of the evidence that we have to correlate with traditional records. So my final slide here is my example from my Benjamin Cox project, where I had some matches to Benjamin Cox through my ancestor Rachel, and they were small. They were all under 20 centimorgans, and I had some, but it wasn't great evidence. So I reached out to four cousins. So they are here in these other colored boxes. I believe I'm purple here. And then they shared DNA as well with these descendants. So these are all children of Benjamin Cox. These are independent lines here. 1, 2, 3, 4, 5, 6 different children. And I mapped out all of the descendancy lines coming down. In yellow are the DNA matches. And then in green circles are how much DNA that each of us shared. So blue here shares DNA, along much of the line. Purple, this was me, so I put in all my matches to get started. And then I started filling in my cousin's matches. So all in all, we had good coverage. We have quite a few matches, and not even all of them are shown here. There's like now about 200 matches on through lines to Benjamin Cox for some of these people. So I feel like I have got a really good, strong proof that he is indeed my ancestor based on the number of independent lines, the number of people who match, and then the documentary evidence that all points to my Rachel being his daughter. Even though no record shows it, there's a lot of indirect evidence, and the DNA was the final piece that really proved it. So, is it easy to prove something like this? No, it's time consuming and it takes a lot of work, but then you can feel sure that you have really finally gotten your conclusion and you can feel good about it.